In Python, I bet you've seen lots of name errors. These occur when a variable is evaluated but not defined. However, have you ever caught a name error? This video will show how the NumPy source code cleverly catches a name error to prevent submodules from loading. The question for you, how is this even possible? To demonstrate, I've created a new module, mymod.py, containing a single undefined identifier. What happens when we import it? The file is executed. The variable is looked up in the module globals and the built-ins. But it hasn't been defined, and a name error is raised, halting our program. At first, this doesn't seem very useful, but what if we instead call it skip import and wrap it in a try except? Now, if the variable is defined, the module loading will cleverly be skipped. Yet we have a problem. How can we possibly define the variable skip import outside of this module before we import it? It seems impossible because in most Python code, you can just look above any identifier and understand where it was defined. Here, there is nothing above our identifier skip import. So we already know this will be a major hack since it defies expectation. Can you figure out how the NumPy developers may have implemented this? Well, let's reason about it. Some names are defined here already, the built-ins, like print and NameError itself. Maybe if we can add to those built-ins, we can indeed predefine this variable. And yes, this would be incredibly hacky. But it turns out Python includes a module called built-ins. When imported, we get a module object with an attribute for each built-in. For example, built-ins.print is print, and built-ins.NameError is NameError. They refer to the same objects. Now, if we add a new attribute, skip import, will that magically become a built-in? Let's try it. built-ins.skipimport equal true. And then magically, skip import is in fact defined as a built-in without the built-ins qualifier. Trying it out, when we import our module, it no longer runs the except clause. So these built-ins, they're sort of like super global variables. They're defined everywhere, even across modules. And this sounds really dangerous. For example, if every module modified them, we could end up with naming conflicts and unexpected values. In fact, that's exactly why Python institutes module namespacing in the first place. So we should never really use this hack ever in our code. It could lead to very non-obvious bugs. But the package NumPy does use it. In fact, it's used every time you import NumPy. So why might it be a good idea for NumPy? Well, let's investigate. We'll see the hack in action in the NumPy source code. First, NumPy is a package, not a module. So in the NumPy directory, there's an init.py file which is immediately run. By the way, if you're coding with me, my NumPy is built for development in place, and my IPython has auto reload enabled. And so any changes I make to NumPy Python files are immediately reflected, like adding this print statement. At the top of init.py, we have a few imports, followed by a similar gate variable called NumPy setup. This try except is very similar to ours. If NumPy setup is defined truthfully, like in the built-ins, then we are assumed to be installing NumPy, in which case we write to standard error and skip importing sub-packages. NumPy skips them during installation because these sub-packages may not yet be compiled, since many are written in C and Python. In the typical case, when NumPy setup is not defined or defined falsely, then we follow the else clause and load the sub-packages as usual. And so now for the fun part. Let's pretend we're installing NumPy. We'll add NumPy setup to the built-ins. Then we'll import NumPy. And indeed it works. We see standard error written to just as expected. The question still remains, though, does NumPy add this as a built-in in the setup script? To verify, we'll open in the root directory setup.py. This script is often run when installing NumPy. We see at the very top import built-ins, then shortly after we set NumPy setup to true, just as we envisioned in our puzzle. So how can NumPy get away with such an ostensibly lousy practice? Well, it kind of works here. Adding a built-in only happens exactly once, when installing NumPy in a completely controlled environment, not in end-user code. Second, the variable added, unlike our skip import, is extremely specific to NumPy and unlikely to be used elsewhere. Third, the code indicates that although hacky, it is the best of the worst solutions they found. It's reliable compared to others. And what alternatives might they have had? Well, the canonical solution for this is to set an environment variable during setup that doesn't exist otherwise. This would certainly be less hacky, but it's also more complex, relies on the operating system, and perhaps is more prone to error, given all of the environments NumPy is built in. So you now know a bit about what NumPy does when you import it, and we've explored a hack using the built-ins. You probably shouldn't use the hack, but at least you now know when and why to break the rules.